Okay, we're going to finish up 6-2. I thought the other day that we would not do this. I didn't put it on the quiz, so you don't have to worry about that being on the quiz, but it's a very strong possibility this is going to be on the test. All right, so, and we're only on 6-2, so the test is not going to be for a little while, but this is something that's going to be on here, okay? I talked about this yesterday. I think I said that the algebra on this was a little tougher than what you've been doing, but I thought about it, and I thought that I think you guys can handle this, because I think we have done a little bit of this kind of algebra in the past. So here it is. Just barely fits. There it goes. All right, so what you have to do is, let's see, what do they ask you to solve for? They ask you to solve for all four sides and the angles. Yep, all four angles and all four sides. That's what we're trying to find, okay? So solve for, I'll just say it like this, all the angles and what? All the sides. And they tell you something. They tell you that this is a parallelogram. This is how they do that. They just put the little parallelogram symbol there, and they say it's JKLM, JKLM, and they use the word given. All right. So if they tell you it's a parallelogram, there's a lot of things we know about this thing because it's a parallelogram. What are some of the things? Let's do the sides. No, let's do the angles. Let's do the angles first, since I put angles right there. What do we know about the angles if this is a parallelogram? What do I know? This is the easiest one. What do I know about angle K and angle M? This angle here and this angle here. Why are they equal to each other? Because they're opposite. Very good. It's exactly what I wanted to hear. Okay, because they are opposite each other. So what's this going to be? 13A. And what's this angle down here going to be? 7A. Everybody good with that? Okay, or you could look at it this way. You really didn't even have to know that, to tell you the truth. Now I think about it. What do you know about the consecutive angles? The ones that are next to each other, like this 7A and the 13A. They're obviously not equal to each other, but what are they? Parallel. Angles are parallel, you're not even thinking. Okay, you're just saying words, and you're not even thinking about what you're saying. Flipped? They're flipped? What does that mean? No? Give me a word. Give me a good geometry word. If they're next to each other, we call them what kind of angles? Consecutive angles. Thank you, Io. Okay, they're consecutive angles. Okay, they're not congruent because they're not equal to each other. This is 7 times A. This is 13 times A. There's no way that they're equal to each other. Okay, this one's bigger than this one. All right, but they are consecutive. What does that mean to be consecutive? They add up to 180. Okay, they don't equal each other. Okay, consecutive angles, okay, are supplementary. Remember we talked about that? Okay. One person did. I don't know if anybody else did. But anyway, these are consecutive angles. These are consecutive. These are consecutive. These are consecutive. So really, I didn't really even have to know that this angle, well, anyway, it is true that these are equal and these are equal. But what I'm going to do is I'm going to take the 7A and do what with the 13A? Am I going to set them equal to each other? No, because they're not equal. What are they? They're consecutive, which means they're supplementary. Right? So consecutive angles. When I got a parallelogram, I got parallel lines and a transversal. The consecutive angles of a parallelogram are supplementary. So what does that mean? They add up to 180. So let's do this. 7A plus 13A, what's 7 plus 13? 20. 20 what? A equals 180. We should be able to do this without a calculator, shouldn't we? Divide by 20, divide by 20. Look what happens. Zeros cancel. So what do we have? 18 what? Divided by 2, which is 9. It's not what they asked for, though, is it? They asked for all the angles. So how do I find this angle right here? Put in the 9 in for the A. Exactly. Substitute. That's a good word, too. 7 times 9 is? Let's do the work. Let's do it right here. 7 times 9. What's 7 times 9 without a calculator? 63. Correct. So that would be 63 degrees. What would angle L be equal to? It's also 63 degrees. Now, how do I find this one? I could go 13 times 9. 13 times 9 is not one of those things that I really have memorized. Is it for you? No. But you could do, what else? That's right. You could go, well, plus 90. Is that what you said? Oh, I see what you're saying. You're just doing the arithmetic. Okay, I see what you're saying. You could do that. Or I think what might be easier, let's say you didn't have a calculator. If you did have a calculator, I would just go 13 times 9. Right? Easy as that. But if you did not have a calculator, I think this might be a little bit easier. You know this is 63. You know this is what? 180 what? Minus 63. Very good. And that gives you 117. All right, so that's maybe a little bit easier way to find it. Or you could just go 13 times 9. If you wanted to, wouldn't be that much difficult to do this. 13 times 9, remember this? 9 times 3 is 27. That's 9 plus 2 is 11. There you go. You still got 117. Everybody with me? All right, so that's 117. What's angle K going to be? Yeah, it's 117 because these are equal. These are equal. There you go. You found all the angles. Make sense? All right. Okay, let's find all the what? All the sides. Now that was the easy part, finding the angles. Okay, that was the easiest part of this. This next part is going to be a little bit trickier. All right? Setting it up's not a big deal. Doing the algebra is a little bit different than what we normally do. All right, so I'm going to show you a nice technique to do this. So what do I know? How do I find the sides? What do I have to do to find the sides? What do I know about the sides? They're all equal? They're not all equal. No, they don't add up to anything. Not sides. Okay, the sides are parallel, but that's true, but that's not really going to help me solve for x and solve for y. What else do I know about the opposite sides of a parallelogram? Nope, they don't add up to anything. All right, that's only angles that add up to stuff, not sides. Say it. What's true about this side right here and this side right here? They're parallel. That's true because it's a parallelogram. Come on, this is something that we just talked about on section 6.2. What's something special about the opposite sides of a parallelogram? Brandon, tell me. Okay, they're congruent. Who said that? Donnell? All right, thank you. They're congruent to each other. They're equal to each other. The opposite sides are equal. Everybody got me? So look, what's true about the 2x and the 5y minus 2? They're equal. So I'm going to write it. 2x equals 5y minus 2. We got a problem though. All right, what's the problem? There's no x here. There's an x here and a y here. Are you able to solve, listen, are you able just to use this equation and solve for x and solve for y? No, because if I get x by itself, I divide by 2, I still got a y, and I don't know what that is, do I? So I'm stuck. Well, kind of. Look, what's true about these opposite sides? They're also equal or congruent to each other. So I can say that x equals what? It's not x, it's a what? It's a y. 2y plus 1. Everybody see that? Now, here's a situation. I'm going to teach a little bit of Algebra 1 right here. This should have been taught, but apparently you didn't see it. You remember it. If you have two different variables you're trying to solve for, what are the two variables we're trying to solve for? X and y, okay? You must have two equations to be able to solve for it. I can't just take this and then find out what x is equal to. Would you agree? Okay, if that's all I knew. I couldn't do that with the second one either, right? But I can do this. If I have two equations and they both have x and y in it, I should be able to solve for x and y. So we're going to do a thing called substitution. So do I know what x is equal to? Kind of. I don't know exactly what number it is, but I kind of know what it is. Do I have x equals something here? Yeah, so what's x equal to here? 2y plus 1. Very good. Okay? So what I'm going to do is I'm going to take that 2y plus 1. Now, in both of these equations, this x is the same thing as this x. This y is the same value as this y. Okay? So what I'm going to do, since x is equal to 2x plus y, guess where I could put that? Substitute it. Very good. I like that word. Substitute it in for that x. Do you see it? It's kind of, we did that substitution here, didn't we? We found what a was, and we substituted it. And for this a, we went 7 times 9. Agreed? We're doing the same thing, except we don't know it as a number, but I do know it as 2y plus 1. So I'm going to take that 2y plus 1, and I'm going to substitute it in for this x. So what is that 2 and that x doing to each other here? It's 2 what? 2 what x? 2 plus x, 2 minus x, 2 times x, 2 divided by x? What is it? What is it? Is it 2 plus x? What is it? It's 2 what? Times x. Thank you. It's 2 times x, isn't it? That's what 2x is. It's 2 times x. So I'm going to go 2 times, right? In algebra, we use parentheses for times. Times what? You got it. 2y plus 1. Okay? So that's this right here. Everybody see that? That's the 2x. Let's continue that second equation. 2x what? Equals what? 5y minus 2. Now check this out. Now look at this equation. Now, does it have 2 different variables now? Nope, it's only got 1. So what can I solve for now? I can solve for y. See that? So I did a little substitution. I replaced that x with a 2y plus 1. How could I do that? Because 2y plus 1 is equal to x, right? It's the same thing. So I could just take that x and substitute that in for it. And now I have all y's. So now we're back to regular, quote, regular geometry, okay? So let's do it. What do I do with this 2? Yeah. So what do I get? 4y plus 2 equals 5y minus 2. Let's do the math. I would subtract a 4y from both sides. Yep, and that would get rid of this 2 right here. I would add a 2, and I would add a 2. So that cancels, that cancels. Let's do the y's first. 5y minus 4y is y equals what? 4. So y is equal to 4. How does that help us? Well, that means I could find this side and I could find this side. Let's do it very quickly. 5 times what? 4, which is 20, minus 2 is 18. Does that mean this is 18 as well? No. Okay, but this side right here is, isn't it? So I don't even have to solve for x, do I? Okay, if I know that's 18, I know that's 18. What about this side right here? 2 times what? 4, which is 8, plus 1 is 9. So that length is 9, so tell me what this is. That's also 9. And there you go. You found all your sides, you found all your angles. So this is the only thing that's kind of new for you guys. I don't think we've done this before. That's substitution. But that's something. Do you remember doing this in Algebra 1? Yeah, you probably did this in Algebra 1 for sure. Okay, let me show you one more thing. I got like 2 minutes left. This will be super quick, and it's kind of easy. So what if I had 3 parallel lines? Usually we have what? 2 parallel lines, don't we? Yes. This time we're going to have how many? 3. All right, and I'm going to try to evenly space them out right here. Now check this out. I'm going to make a line go through like this. I'm going to make a line go through like this. Okay? So let's call this A. Shh. See, nobody else is laughing, Ben. You're the only one. So it means it's not funny. So let's take a look. What if I told you that this little segment, AB, is equal to this little segment, BC? By the way, what did I say about all 3 of these lines? They're parallel, okay? This only can be true when these are parallel. So watch this. If AB is equal to BC, tell me something about DE and EF. They are also equal to each other. Watch. If that was 3 and that was 3 and this is 4, what do you think this is going to be? That's going to be 4. There you go. So we finally finished section 6.2. You could see some of those things on the test whenever we have the test. It's not going to be for a while, but there you go. We're finished.